4. Nodal lines and antinodal lines. An interference pattern consists of alternate nodal lines and antinodal lines. We may now tell the path difference at each line, starting from 0 from A0 in figure 5.4n. Please copy that down on your book. Five. Conditions for steady interference patterns. In the above discussion, the sources S1 and S2 are driven by the same motor, and so they are vibrating in phase, so that they must be coherent. What if they are in antiphase? In example 7, interference patterns of sources in phase and in antiphase. In part C, the two sources are vibrating in antiphase. You can deduce that the dotted circular wavefronts are used to represent trough produced by S2, while crest is produced by S1. You can deduce the position of constructive and destructive interference interchange when the sources become vibrating in antiphase. Examining 1 may test whether you have some common misconceptions found in most students. Note that for observable interference, the sources may be vibrating in phase, in antiphase, or just out of phase, but their phase difference must be constant. And when two sources have a constant phase difference, they are called coherent sources. So, for an observable interference, which is an interference pattern not changing too quickly, the two sources must be coherent, at least within a reasonable period of time.
We will see how water waves are interfered in different situations by using a ripple tank. Fix the two dippers about 5 centimeters apart on the bar of the vibrator. Observe the wave pattern. Increase the frequency of the vibrator so that the wavelength of the water waves is decreased. Observe the effect on the wave pattern. Reduce the separation of the dippers. Observe how the wave pattern is affected. Form 2 narrow gaps in front of the vibrator. How is interference produced by using 2 narrow gaps?
6. Factors affecting interference pattern. An interference pattern is affected by the wavelength lambda and source separation d, as shown in the experiment that follows. For the shorter wavelength lambda, or a larger source separation d, the interference pattern becomes more closely packed, and the number of lines also increases accordingly. By the way, we may use a single source to produce interference pattern as shown in the following figures, as the pair of sources in these cases must be coherent, so interference pattern must be observable. 7. Diffraction and interference as the tests for waves. You may note that interference is a result of vector addition of displacements from coherent sources. For destructive interference, the resultant becomes smaller. There is no destructive interference when particles meet, so interference may only apply to waves. Indeed, diffraction is a special kind of interference, and so diffraction is also unique to waves, and therefore diffraction and interference are both unique to waves, and they become tests for wave properties. So if something can perform interference and diffraction, it must be a wave. In book E2, you will see electron can also perform interference and diffraction, and so electron has a wave nature. Try checkpoint 6 below.